Ladies and gentlemen, hello. Thanks for waiting. I do apologize for being late. Hopefully you can all hear me. I've literally just walked in the door. Say hi if you're here. Say good day in the chat. My name's John. I'll be hosting tonight.
Hello.
Hey, how's it going?
Hey, I'm well. Apologies for being late. The one day in months that I have to go out of the house for work and I run late. That's all right, we will make do. Okay. Has everyone completed the pre-workshop tasks? Has anyone not completed the pre-workshop tasks? You can tell me what version of Git they're running. Paste it up in the chat. Excellent. At least one done. Is it anyone's first time using the command line? Excellent. Speak up if you haven't done the pre-workshop. No shame. I'm completely late, so. It's not too bad. It's just a little introduction to the command line, navigating through your computer, using the command line, getting Git installed, and setting up a GitHub profile as well. Should be all the things that we will have a crack at. Okay. Share that. Share that. I'll post up the slides for you guys. I'll paste a link in a second. So there's a link to the slides, guys. All the content that we'll be covering. Okie dokie. And one more thing I need to do, and then we'll get cracking. All right, let's jump in. Sorry, I'm a little bit flustered, but we will crack on. Yeah, my name's John. I'm going to be hosting the Git workshop. This is the second time it's run. First time was last semester. Both of them been online. And I would like to say that I've worked out all the kinks, but I haven't really touched it since last semester. There wasn't too many kinks, so should be pretty straightforward. What we will be doing is a quick little. Basically, there's a fair bit of information that we need to absorb when we talk about Git. So a lot of it's new terminology, a lot of it is a bit of a new concept, but we'll be working through a sort of toy example to get us used to it in the first part. And then in the second part, we've got a decent number. So in the second half, we'll also switch to the more collaboration style of Git, where we can use GitHub and get involved with that. So we'll see how we go. The first part's all individual, located on your computer, and the second part, yeah, we'll get into the collaboration side of things. So this is roughly what we're going to be covering in the first little bit. Again, a lot of it will be getting used to some of the common terminology and commands. Git is something called a version control system. There's people usually talk about Git to encompass all these things that are VCSs, but there's a bunch of other ones out there actually. CVS, Subversion, and Mercurial are probably the main ones, as well as Git. Git is certainly the most popular and is pretty much the industry standard now. And was popularized by use on in developing the Linux kernel. They realized that these products that were available at the time weren't cutting it, so they developed their own version control system, and that's Git. And now it's this huge thing that almost everyone uses. Basically, going to help us writing code and managing, collaborating on progress on different projects. So, interested to see what sort of coding everyone's doing. Part of uni, or anyone got any hobby or work coding that they do? What sort of languages are we dealing with? I suspect there's lots of MATLAB if you're doing engineering. I do a lot of stuff in Python. Yeah, Python. So nice one. C++, very good. So yeah, that's all about managing the code that we write in the languages that we use. So I think Git was written in C, I want to say, as most things are that sort of run like this does. But yeah, it's basically used to manage any sort of code. And as we'll find out, not necessarily code either. Doesn't need to be code. That's what it's mostly used for. And we're all guilty of this, right? This is what Git is going to help us avoid. These bad naming conventions where you have no idea which file's the actual right one, because we end up down a path like this. It's a little bit of a steep learning curve, and sometimes it's not really useful to use Git. It's certainly good to learn, but places where we definitely want to use Git is any sort of long-term project where code is changing a lot, where code complexity is high, where you're sharing code with other people, collaborating and things like that. Certainly Git or some sort of version control is almost 100% necessary. Maybe you want to use it to help get familiar or keep your skills up if it's only just code that's used by you or just a couple of files. Like I probably wouldn't be starting a Git repository for your next assignment that's just one MATLAB script. Probably not quite worth it, but yeah, certainly any bigger projects like a capstone project where you're dealing with lots of people, Git is a great idea. And if you want to jump in and use Git with one of those smaller projects, it's a good place to get familiar with it, and yeah, sort of don't have to worry too much about breaking things. So at its core, Git is, as you hopefully found out from the pre-workshop, I like to at least learn how to use Git from the command line. That's what it is at its core. It's a command line tool, something that we use interact with at the prompt. So if you haven't had any command line experience, it can look quite daunting. It's pretty easy actually. But by using Git at the command line, you can certainly access all the features that Git has to offer. It's going to work almost identically across any platform. If you're, say, doing a lot of coding on a server, you don't necessarily have an option to use a GUI. All you have is a command prompt to sort of manage your code with. But once you know what you want to do and you know the terminology and can do some basic stuff with Git via the command line, you'll be able to use any interface that's provided for Git. So a lot of GUIs, people have developed GUIs to interact with Git. One's called Source Tree, Git Kraken, MATLAB actually has its own built-in sort of interface for interacting with Git and that sort of version control management. And GitHub, of course, is an online tool for managing repositories. And I believe GitHub has their own desktop GUI as well for doing the Git interaction that we'll see. And there's a bunch more. So I'm coding in Python. I use PyCharm personally as my IDE. You know, all the other big software IDEs are probably going to have some sort of way of interacting with Git. And yeah, certainly Bitbucket. I use Bitbucket for work. It's an Atlassian product. Same sort of thing. We'll learn about what particularly Bitbucket and GitHub are all about, and what the difference is between like Git and GitHub, because there is a difference. They're not the same thing. And Atlassian or Bitbucket and all those other, I forget the other ones. Microsoft just bought some. GitLab is another one. We don't specifically talk about GitLab, but again, GitLab sort of comes in the that's in the same family as Bitbucket and GitHub in what GitLab actually does. So once we learn how that all works, you'll be able to go and say, oh, if I want to use GitLab for this project, then you'll be able to apply this knowledge there. But we don't talk about it specifically. We use GitHub for today's one, which is sort of one of the biggish popular online Git repo storage places. We'll learn some of the common terminology. This is an example of the command structure. Usually the command will start with Git, and then we'll have some sort of command and maybe some sort of option and an argument. So if you've done the pre-workshop, then this will make sense, and we enter these at the command line. But once you know the workflow and the thing that you're actually doing, what you're achieving by issuing those commands, you'll be able to use any of those interfaces that you like. So you've heard me say repository or repo a few times. So a repo is a collection of files and directories that are managed by Git for any particular project. And they're all located in a single top-level directory. And a Git repository or repo contains not just the files themselves, but information regarding their history. So version control, it's about managing how your code changes and be able to go through different states of how your code has existed. So that's the important thing about Git. Manages code history, not just the code in its current state. And these are some ways that we can create Git repositories. Init or cloning, if we're cloning a remote repository, as it turns out. They can come from a URL. And don't worry, you'll get a chance to test some of these out later. A commit. So commit is a very important terminology. A commit is a specific snapshot of the state of the repository. So it's like a little save point for yourself. And it includes either all or maybe like a subset of certain files that you want to take this snapshot of. And choosing the particular files that you want to commit is known as staging. So that's important. You first have to stage some files and then you commit them. And each commit is just identified by some sort of hash. So sometimes you'll see a big bunch of jumbled letters and numbers, which is the hash, and then they'll have a user readable message that you put in to sort of name what that particular snapshot is of your code. So it's one of the most important things when you're managing your code with Git. You want to make sure you commit your code frequently. And if you do, you'll never be afraid of breaking things, because all those little save points, you can go back to any one of those or any sort of combination of them at any time. You can easily go back. This is how we might stage and commit some files. So git add is a command here, and then git commit with an M option, and then our commit message will look like this. So that's what happens when we commit. That's what it looks like. So that would be taking a snapshot of our code, and that one would be called commit message. And we could look at that. This little thing down the bottom is basically the sort of standard way of showing how your code tracks. I mean, this is just one commit here as a circle, and then we move from one commit to the next commit with a line, and that's the other circle here. So circles are typically commits when we look at things graphically with Git. And hopefully I'm not going too fast or too slow. I'll just keep plowing on. Feel free to pipe up with any questions. I'm keeping an eye on the chat too, so post them up if you need to. Some XKCD for you. Yeah, certainly guilty of this. The later in the night it is as well, the worse your commit messages can get. So I always try and keep them nice and legible, and you know what they are. So, and we can see down the side here, here's some commits with the dots and like that. So another important thing is a branch. So a branch represents a divergence in the state of our code. We typically will use a branch when we want to keep some of our code stable, but we also want to work on something else at the same time. So we want to sort of have a snapshot of our code here, and we want to say, okay, we'll take that idea, we'll move it over here, and we'll keep developing. So we branched off, or diverged our code for a new path of development. And so typically we'll see something called a master branch in a lot of repositories, although I think that potentially may be changing for a few ways to interact with Git. Sometimes main is another common one. So a large project would typically have like release branches. So like a version number would be on one branch, and then the developers would be working hard late into the night developing the next version, and that would be happening in a different branch, sort of being developed. They'd be committing on that branch, and then eventually it comes time to do the next thing. These are some of the commands that we use when we're interacting with branches. So we can create a branch. Incidentally, we don't switch to it if we run this command. We can check out a new branch, which would switch to that branch. We could create a branch and switch to it at the same time with this, with the B flag. We can delete a branch with the D flag. And here's how a branch looks in sort of graphical Git. So you can see if we're coming along from left to right, here's a commit, a snapshot of our code. Here's another commit as a snapshot of our code again. And then all of a sudden we've diverged. So this branch here, it's got some different commits here, but it's based off these two commits beforehand. This commit is separate from these two. It's separate from this branch, but it shares these two commits in common. So you sort of get this idea of how your code sort of is all related to each other by this idea of branching and commits and how it flows. It's very similar to graph theory. The opposite of creating a new branch or doing a branch is a merge. And that's instead of a diverging state of code for a branch, this is a converging state of code. And it combines the content, which is the commit. So all the content is stored in a particular commit, that snapshot. Combines a commit in one branch with the contents and commits in the other branch. So this can be easy sometimes if the branches are distinct and it knows how to combine the files. Sometimes it can be hard if the files have conflicting content, because Git doesn't necessarily know which one's the correct one to use. So this is known as a merge conflict, and that's where we want to need to correct them manually. Merge conflicts can be a little bit of a pain. And yeah, that's pretty much the thought that you have when a merge conflict comes up. It's not a fun time, but they happen. So here's what a merge looks like in our branching model, our graphical model. And this command here would merge new branch, or the branch that's called new branch, into whatever branch we're currently on. So if we're on this gray branch and we said git merge blue branch, that would perform this like that. All of those commands are for working with a local Git repository. So this is what happens when we sort of work on our own code and it's just us working on a project. We'll usually have a local repository. So everything exists on your computer. When it comes time to share and collaborate, you don't want to do the old emailing of code. So I need some way for someone else to access the code that we want. And this is where a remote repository comes in. So it's called a remote repository. So remote repo is hosted by some provider. So GitHub, GitLab, Bitbucket, all those sorts of things. They're providers of a remote repository hosting service. Sometimes they'll give a online interface for simple actions. So if you go to the GitHub online website and go to a repository, you can usually commit, branch, or merge via your web browser. But its primary function is to provide access to a repo to whoever's allowed to access it. So if someone else needs to access your repo, you need to put it up on some remote hosting provider's service. So GitHub, GitLab, Bitbucket. So notice how Git itself is completely different from GitHub, GitLab, and Bitbucket. So I want you to really understand what role these guys are playing versus what role Git is playing itself. And here's what happens. Here's how we use the two local and remote repositories. So a local repository on your computer, that's where you're actively developing your code or using the code for its intended purpose. So it could be a library that you've downloaded or some sort of software tool that you've downloaded. It may exist in a local Git repository, so you could be changing it or tweaking it, but you're basically using it for its intended purpose. The remote repository, you could be using it for backup purposes or sharing and distributing your code. So you don't actually do any development on a remote repository. That's not where you're doing your work. You're doing your work on a local repository and interacting with the remote repository in some way through commands such as push and pull. And don't worry, we'll get a chance to practice all this later. And yeah, have this up on your wall if you're working on any serious code. In case of fire, git commit, git push, and then leave the building. That way your code is pushed up onto the remote repo. It's all stored safely somewhere else. It's someone else's problem. If they have a fire, who knows? There's plenty of other Git commands. This is only really scratching the surface, and I know there's a lot there so far. But typically, they're all used to manipulate branches or commits on either your local or remote repository in some sort of way. So that's sort of what we're doing. Branching, committing our code, and then interacting with the remote repository as we need to. Right. Any questions so far? Take a bit of a breather. It's a lot to take in. And yeah, pretty much good old XKCD again. Sometimes you just need to memorize those commands. All right. Can everyone post up the version of Git that they're running into the chat? There's mine. here's how we issue it. Anyone having issues? Good, good, good. Yeah, we certainly can return to old commits. We'll get some practice at that. Good, good, good. Okay. Everyone practiced navigating through the directory structure? Got some windows. Anyone else on Mac? We're going to start jumping in now. Anyone on Linux? Yeah, got another Apple. Good. Okie dokie. So here is all the stuff that we're going to be covering by getting our hands dirty. So hope you're ready. Let me know if you get stuck. Okie dokie. So initial setup. If you've never used Git before, we're going to have to do a few little things. And for this, we're not actually going to be writing any code. We're just going to be using our favorite text editor. And this project's going to be a simple little tool for managing our university courses, right? So Git is not specific to code. What Git does, it beautifully looks at text, plain text files, and knows how to see what differences there are between similar versions of the same file. So we can just use a text editor, edit plain text files, and Git will help us to manage the differences between those files. So code is just a plain text file. Sometimes it'll have a fancy extension like .m or .c or, you know, .cpp, anything like that, but they're just plain text. They just contain plain text. We're not dealing with compilers. We're not dealing with any of that, binary files. It's just plain text. So Git does a great job at that. Okay, so if you're a first-time user, you're going to want to run these commands to get yourself set up for the first time. So first one is setting your Git identity. And so setting your name that's associated with all of your Git projects. So run this command. You can copy and paste it in, just make sure it works properly. And then just where first and last name is, put your first and last names. Okay, so that would be git config -- global user.name. And for me, I'm called John South, like that. And now hit enter, and that should do it. I've already got my Git set up, so I'm not gonna run that command. You guys should though if it's your first time. Second one, we want to set up the email that's used. So these are associated with commit. So similar sort of thing. Set up your email. Just put in the email that you use to sign up for the GitHub account is probably the best one. And then we need to set up the remote credentials for yourself. So this is what's tied to GitHub. Again, I'm probably going to run into a bit of trouble later because I've got a fair few different Git credentials floating around, some for work, some for hobbies. But if it's your first time, just set this up with your GitHub account. So this part stays the same. The bit that you change is the end part where you just put in the username for your GitHub account that you've created. And once you've run those three things, throw up the little tick in the Zoom participants so I can see if you're done, see if anyone ran into any problems. There should be a little green tick there if you've completed those three with no issues. If you do run into any particular issues, sing out. Part of the trouble with these ones is getting set up for the first time. So I want to make sure that you're all set up and good to go. Yep. So Luke, have you downloaded and installed Git as per the pre-workshop tasks? Yep, that's all right. Let me pull up that pre-workshop. Luke, you on Windows or Mac? Windows, sweet. Try that one. And when you install it, you'll probably need to exit out of the command prompt and start it up again once it's installed, so it has access to the thing that you've just installed. I'll put up the link to the pre-workshop document as well. If you're feeling brave, feel free to start moving through. The first part of the workshop is pretty much a guided activity. So you can just follow through the lecture slides if you want to soldier on ahead, and let me know if there's any problems. Otherwise, I'll be working through it as well. I'll just give it a couple more minutes. Hopefully, we may not be able to get everyone. I'd like to see a couple more green ticks. So just remember to throw up those green ticks if you're following along and have run these 3 commands successfully, or you believe you've run them successfully. Excellent. So these are obviously, we're using the global flag here, guys. So this is going to set up Git to use this information for all of your Git projects. You can set that up per project as well if you want to use different information per project, which can be useful. Okay. Next one, if you're on Windows, you're going to have to set up a Notepad editor to be the text editor that you want to use. So sometimes, not all the time, but sometimes Git will need that text editor. And this is the way that we tell it to use Notepad. If you're on Mac or Linux, typically Nano is an easy one to use. I use Vim sometimes myself, but yeah, we can specify Nano to be your editor there. If you're old school, you might use ed for editor, for some sort of command line editor. But yeah, this is how we would do it. Okay, I'm going to start creating a repository. So first thing to do is navigate to a suitable location for the project. So in the pre-workshop, we talked about some common commands, changing directories, listing the contents of your directory, ls if you're on Mac, dir if you're on Windows. So I'm just going to navigate my way through to a suitable location. I can remember where I need to go. So I'm now in the location that I want to create my directory in. What I want to create my repository in, rather. And to do that is to run this command. So git init for initialize, and then the name of the repository. In this case, we're going to call it course manager. Okay. So I do that and I get a little bit of feedback saying initialize empty Git repository in this location. Excellent. If I have a look at this directory now, I've got this other directory that's just called course manager. It looks like a regular directory. We can have a look at that directory through our usual way. So on Mac, it's called Finder. So I'll just pull up Finder and navigate to the location that I just created that repository in. We'll have a look at how it looks. So here it is. It's just looks like a directory. And at the moment, it looks empty. In my command line, I can do ls. It's just got course manager in that one. I can change directory into the course manager and list all the things, and it's empty. Well, it looks empty. There's actually a bunch of stuff that Git has created in the background that we don't see by default. So if you want to see where it is, you can do ls-a, and you can see there's actually this thing called .git, which is a directory. So I can actually change directories into that .git folder. And now if I start listing things, I can see there's all this stuff in there. We don't actually need to touch any of it when we're doing things usually, but it does exist. It's there. It's called a hidden directory or a hidden folder. Here's what it looks like. Here's all the stuff inside it. So that's the directory structure of that hidden Git folder. There's our course manager, top level repo, and that hidden Git folder. Nothing else at this stage. So when you're creating things, you just want to be in the course manager main directory, top level directory. We don't ever need to go into this Git directory. We don't ever need to interact with it if we're doing things properly. So there's a couple of helpful commands that you will learn to love to run a lot is git status and git log. Git status says there's on branch master, there's no commits yet, and there's nothing to commit, which makes sense. We haven't really done anything yet. Let's try git log. Our current branch master does not have any commits yet. So that's some ways to some very common git commands. If I'm not in a repository, so remember my semester 2 folder is not a repository. If I try and run those commands outside of a Git repo, we get an error that says it's not a Git repository. So there's no hidden .git folder there. But if I'm inside that course manager repo that I created, then Git knows what it's doing and all these Git commands will work. Right. Everyone up to date? Anyone still having issues? I'm going to keep soldiering on unless I hear otherwise. Happy to answer any questions that come up as well. So first thing that we're going to do is add some basic content to our repository. In a lot of repositories, you're going to see a README file, readme.md. That usually gives a basic overview of what the basic function of the code is. .md, if you haven't seen it before, it is Markdown. And it's going to give access to some basic formatting like bolds and italics. You can it's still just a regular text file. It can be human readable though, but also if we have something that renders a Markdown file, it can look quite nice as well. So we're going to firstly open a simple text editor to do our interactions. If you're brave, you can use a command line text editor. You know, Vim, Nano, Emacs, whatever. Don't use Word. It's not a plain text editor. Certainly can be a bit of a problem. If you're using Word, don't do it. On Mac, there is the text edit app that you can use for me, that's what I'll use for this one. If you're on Windows, you'll probably be wanting to use Notepad, Notepad++, something like that. Something that can just do plain text. So I will quickly navigate to the repository to create a file in there, just like I usually would if I wanted to create a file in a directory. So here I am, semester 2, course manager. Here's where I want to create my new document, and it's going to be called readme.md. We'll add some stuff in it in a second. I'm just going to add the text "Welcome to my repo" to it, and then I just need to save it. And then just make sure you save it as a plain text document, right? You don't want a rich text. And remember, we need that to be readme.md. And I save that in there. Perfect. So if I have a look in my course manager repository, I've got a file in there called readme.md, as I expect, because I just created it. In my Finder or Windows Explorer, you should have a text file in there, or a markdown file rather, called readme.md in there. So we've basically just added a folder, added a file to our Git repo. Usually you might be doing this with some sort of code IDE, PyCharm, MATLAB. You might be just editing your code away and saving it in the appropriate spot, or VS Code, any of that stuff. As long as it's going to the right spot, and as long as it's something that resembles a plain text file. Okay, so we should have our README in there now. What happens if we run these commands again, the status and the log? I'm still on branch master. I don't have any commits yet. I haven't committed anything, but I do have some untracked files. So Git said, oh, you've just added a file to this repo, README. But it's saying we haven't done anything to indicate it to be committed, or we haven't committed it yet. So that's what we're going to do next. So we're going to do our first commit. So we've created the content that we're happy with. This might be your code. In this case, it's our simple little README. And yeah, we have untracked files. We need to do this staging so we can track the file. So first thing that we need to do is git add README. So that's going to add the file that we just created to be tracked and ready to commit. I remember it's called staging for commit. So we're going to stage the README file for committing. And you can try running git status and git log after each command and see what happens. So we just ran git status. I'm going to do git add README. Don't forget about tab autocompletes. If you type a couple letters and hit tab, it should complete nicely for you. So I'm going to add that, staged, ready for commit. Git status now does something different. So I'm still on branch master. There's no commits yet, but I've got a new file ready to be committed, the README file, because I've just added it and I've just staged it. Now I'm going to do the commit. Git commit -m. So the message is going to be called something nice that I'll remember later. This is the commit. This is a snapshot where I created the README. Okay, and I commit that. And we get this nice little message. Okay. So I can do git status again. I've nothing to commit because everything's up to date. Everything's sort of stashed away. It's snapshotted. If I do git status now, sorry, git log rather, we can start to see some information about the commits that we've just committed. So there's my commit message, created the README file. It's got the date. It's got the author. So this has got my work account here, which isn't great. Should have for you the credentials that you set up in the first couple of steps. Okay. Following along, hopefully. I'm going to keep adding. So I'm going to go back to my README file. It's going to add a little bit more information. I'll be using this to keep track of my uni courses. Okay. So just add some lines there. Okay, I'm going to create a new file called current.txt. And that's going to contain the course code of my current course. One per line. So ln 900557. And then I'm not doing any others. Lazy me, I'm just doing one course at the moment, so I'll leave it at that. Save it into my repository course manager, and this one's called current.txt, like this. Okay, so I've got my two files on the go. Let's have a look at the status of my repository now after creating those two files. Okay, it says I've changed README. So it's changed from what's in the commit, right? Because I added that extra line. That wasn't in the commit. This line here wasn't in the commit before. And I've also got a new untracked file, current.txt. So obviously I need to change the, I need to track that. So I'm gonna stage everything ready for commit. So git add dot. So the dot is gonna add everything that Git has access to stage it for commit. And then I'm gonna do the commit. Git commit with a message, edit the README. So good messages all the time, and add the current courses file. Okay, and we can see here what's happened. Two files changed. We've had 4 lines added and 1 line deleted. So that should make sense. The deleted line could be a line break or something like that. And we can run git log. Now I can see I've got 2 commits in my log. Created the README in the first commit, and in the second commit, I've edited the README and added the current courses file. So we should recognize those commit messages to what we just made. Excellent. Use the clear command. I think it's clear on both Windows and Mac to clear up your command prompt. Give yourself a bit of breathing space. Okay, a couple more things to do and a few more commits. We're going to add 2 more files, completed.txt and planned.txt. Add the relevant course codes to each document, 1 per line. Stage and commit the new files with an appropriate message. So I need to add in my text editor 2 more files. Completed, I don't know, ln 10, 11, I don't even remember. I'll do it twice because I don't remember what courses I've taken. And that's going to be saved into, what did I say? Completed.txt. And a new one for planned. ln, I'm going to make up something because I don't know what courses there are. That's what I'm going to do next semester. And that one is planned.txt. So again, this is just a toy example. It's not really doing anything too useful for us, but it demonstrates the idea of manipulating text-like documents and committing things. So git status, got untracked files. So that's the changes from this one. The only changes are 2 new files, completed and planned. Let's add those, stage them for commit, and then commit them. Add planned and completed files. Great, and there we go. Git status. Cool, and git log. We've now got those 3 commits. So we're working oldest at the bottom, working our way upwards towards the top for newer stuff. So there's the commit messages, and these are the commit hashes, right? So this big long string, this uniquely identifies the hash uniquely identifies the commit the hash does. Perfect. Any questions? Take a breather for a second. You're doing well. We'll keep soldiering on for maybe 20 more minutes, then we'll have a break, and then we'll use the last half an hour to probably work on the remote collaboration style stuff to get you somewhat familiar with that. We did start a little bit late, so I'm moving relatively quickly. So we created our first version of our project, right? It does what we want to do. We've got some basic information. We know what courses we're taking, what we're planning on taking, what we have taken. We're going to improve its usability. I've got some big ideas for this software project, but I don't want to lose this information. Maybe I want to come back to it. I want to compare to it. I want to be able to use it if I need to while I improve the things, because it could be easy to lose track of those courses. So we're going to do a branch. We're going to add this feature on a branch. So first branch that we're going to do, we can use the command git branch to see what branches we have available. Okay, so this is what it looks like when we only have the master branch. This is what we've been working on, is master. I'm just going to close these in the background. Depending on the text editor, it may automatically update the files as you change them. If it's like mine, if it's like text editor, it won't actually change the files if you sort of change them underneath the text editor, what it knows, because it stores them in memory, I believe. So we need to create the improvements branch by issuing the command git branch, and then the name of the branch, which I'm going to call improvements. So that's created the branch. Let's have a look at the output of the git branch command. So I've got master, which we're on, which has got the asterisk next to it and the green color, and improvements, which I've created, but I haven't switched to yet. So I need to issue the second command to switch to that new branch. Git checkout improvements. Okay, and we get a little message saying switch to branch improvements. So let's have a poke around. What's changed? Nothing really. I've got my files that I created. If I look at git log, I now say we see two branches. We've got this thing called head. Don't worry too much about what head is, but head is really sort of where we're at, what commit we're looking at, what we're looking at in our code. So head is pointing to improvements, which means we're looking at what the improvements branch looks at. We also got a master branch. They're at the same line of this commit because they are basically carbon copies of each other at the moment. We just created the branch. It's based on the current snapshot, which is this current commit here. So in my Finder window, in my course manager, I've got all those files as they exist, and you know, the contents of those files is as I created them. I just would need to tell this to open with text edit because it doesn't recognize it. So yeah, we created the branch, but we haven't done anything exciting with it yet. I'm going to use the improvements branch to add the course name to each of our entries. So make sure we're on the improvements branch. So issue the git branch command, and you can see what branch you're on. See my asterisk is next to the improvements branch. I'm going to open up my files in my text editor. I'm going to add in the course name as well as the course code. So completed. So here's my completed ones. What was 3010? Was that signals and systems? I think that was electrical device modeling, maybe. That, I don't know, some course. Right, I can save that, I'm done there. It's my current course. ComSys, communication systems. Planned, the best course. Okay, so that's some new features in these in these files. So we've made some changes. We need to stage and commit them. And when we commit them, because we're on the improvements branch, we're going to be committing them to the improvements branch. We add course names. Okay, that's our commit message. And let's do one more commit. Let's add in one more file. It's going to keep track of our extracurricular activities. So I'm involved with MUEC and ARP. That's my extracurricular activities. I'll save that in, extracurriculars. Yep, added that in, it's saved. We can see our folder structure growing in our command line and in Finder as well. Gonna add that one, so stage, git add everything, and then git commit -m, add extras. Okay. What happens if we want to see what's happening back on our master branch compared to what's going on here? So we can say git diff master. And this brings up a little inline or in command window version of what the differences are between your current branch, for me it's showing up in green, and the old branch for each of those different files. So space gets me through. You can see all the differences between the files there. So that can be really, really useful if you want to know what the difference is. So git diff, and then Q will exit out of that if you need to. Okay, if we need to use our master code at any point and any information with master, we can just switch back to the master branch. We do git checkout master. We see it switch to branch master. Look what's happened back in my folders. I've got no extracurriculars file here because it doesn't exist on the master branch. My master branch only has just the course codes. So there's no course name. We did all those improvements on the improvements branch. I'm on the master branch at the moment, so it's only got the code as it exists. It's only got the code from those commits that were committed to the master branch, which was the first 3 commits. We created the README, we edited it and add the current courses file, and we add the planned and completed files. If I switch back to the improvements branch, not commit, git checkout is the command, improvements, right? Watch what happens to the number of files in my working directory. Okay, extracurriculars has appeared, which is lovely. So if I'm on the improvements branch, I should have, now I've got the course names against all my course codes, and I've got that extracurriculars new file there, which exists on the improvements branch. So that's super useful, right? As I'm developing features, I can just work isolated from my main and master branch in code. I don't even need to worry about destroying it. It just exists and Git keeps track of it. And then as I'm working on my improvements branch, the changes going in, I can commit to that branch and it's all separate. So a good text editor would refresh the file contents automatically. So if I had those files open at the time, we might see the text change, but it doesn't actually happen for text edit. I have to reopen the files after switching branches. So that's how we switch between branches. Let's go back to master and create a new branch. So if I see what branch am I on? I'm on improvements. I'm going to go back to my master branch. So this could be a case like if you're working on your code, you just want to make one little change, commit it. You don't want to make any major changes. It's not developing a new feature, just making one little thing. We still might want to branch off it again. So we're going to create a new branch. I'm going to use a -b flag so I create it and change to it at the same time. So change to that WAM branch. If I look at Git branch now, I've got 3 different branches now, master, improvements, and WAM. What commits exist on the WAM branch? It's the same as the stuff that was in master, okay? Because that's the branch that I was on when I issued the branch command. So if you're on a branch and then you branch off it, it's always got the same commits of the one that you were just on. Doesn't have the same commits that were in the improvements branch. So you've got to be a little bit careful of that. All right, so I'm on my WAM branch. I'm going to create a new file for keeping track of my WAM. File new. I don't know about you guys, but my WAM is obviously 100. And save into, what do they call it? WAM.txt. Perfect. So I've added that WAM file in there. And stage and commit, git add, git commit -m, add WAM tracking. Great. So I've got a new commit on this one where I added the WAM tracking. You can see now this WAM branch has moved ahead of the master branch because it's got a different commit than the one that was in the master branch. So our repository is getting a little bit complicated at the moment. So we might want to view the branch topology. And there's a big list of options here to add with the git log command, but it does format it quite nicely. We can see the state of all of our different branches, what commits are in them, how the branch structure exists. So we've got commit, commit, commit. Here's where our master branch is. That's what exists on the master branch. On one branch, on this improvement branch, I've got 2 commits where I added the course names, then added the extracurricular activities, and then the continuation of the master branch has this WAM tracking in it. Okay, so that's all the commits and all the different branches that I've got. We have talked about head before. If I change branch, if I git checkout improvements, switch to that improvements branch and issue the command as well, look where head changes to. So I'm now on that improvements branch. So that's what head's doing. It's showing you what you're currently looking at. If I wanted to check out a past commit, I could give it the hash that I wanted to check out. So I think there was a question asked about this before. I can copy the commit hash for this one. And I can say git checkout. I recommend you don't do this just this. This is a little bit advanced, but you can watch me. I'm going to check out that commit. And it's giving me this big warning. So I've switched to this commit. I'm in what's called a detached head state. So my head's down here. So my head is not associated with any branch. So this is sort of dangerous because things don't quite work as you'd expect to. So typically you don't want to be editing code in this state. You only want to be editing code from a branch directly. So yeah, but if I looked at the state of my code, I wouldn't have the planned and completed files in here. I've just got up to this commit, edit the README and add the current courses file. Perfect. Let's switch back to, what am I doing next? Nice little memory for you to remember what that big command is. I'm going to check out back to my WAM branch. Yep. There we are, back on the WAM branch. Perfect. I'm going to do some merging. So I've now got all this different code. It's in different branches because I may be working on it differently. I want to keep it separate. But now's the time. I'm happy with the way that it works. I want to start merging everything back into master. I'm going to consolidate my code so everything exists in the one spot. I've just got that one master branch. So that's merging. First, we want to make sure we are on the master branch. So git checkout master, switch to branch master, that's good. Then we're going to merge the improvements branch in like this, git merge improvements, and see what happens. Git merge improvements. Okay, we get a big message. Updating the commit hash. It's called a fast forward merge. You can do some reading about that. Fast forward merge is the easiest one. You can see how lines have changed between that thing. Let's check out our branch topology. So now look where master and improvements are. So they're at the same spot. They've got all the same commits because we merged them into the same thing. So also want to merge in WAM as well. Git merge WAM. Okay, and we get a little bit of a issue here. The merge may not have been completed because we can't resolve it because there's a commit on the WAM branch that doesn't exist on the master branch. Right? We should understand that. We added in our WAM tracking file and committed it. It doesn't exist on the master branch. It can't merge them. It must make a specific new commit here. So this is just the merge commit of the commit message. So I'm going to write that. This is using let me know how that goes if you're following along. That was using Vim to edit. If you're on Windows, hopefully if we've done the setup correctly, that message is going to pop up in Notepad. If you're on Mac, it might pop up in Nano to edit it. So a little bit tricky when we come across a merge conflict. Now we can see our branch structure here. So it's merged in the WAM branch here. But we've got all the commits that we need to. We've got our WAM file here. We've got all our updated course codes. All the features that we added are now on the master branch, which is awesome. So we created the merge message using command line, and once the merge is complete, view the repo state and the branch topology. Just done that. But these other branches are still hanging around, so do a bit of cleanup, and we want to just delete those other branches that we don't need anymore. We could keep them if we wanted to. We could go back to them at any stage. But typically, once you've merged, you don't necessarily need to keep them because you've got all the commits anyway. If I delete those branches, git branch -d improvements. Get the message that we deleted the improvements branch. See, it's gone from there, and I can delete the WAM branch as well. And the branches are gone, but you can still see that the commit and branch structure is still preserved. So we know exactly how it sort of moved around, but the actual branches are gone. We can't switch to them directly if we wanted to anymore because we just deleted them. Perfect. Contents of the file. Yep. They're still set up. Perfect. What happens if we mess up? So something going wrong, changes causing too many crashes, or just changed our mind. So we've seen how to switch between branches. So hopefully using those properly. But if something goes very wrong, say for example, I accidentally deleted all my files. Whoops. And then I accidentally emptied my trash bin. Whoops. How would I get these back? We'd be in big trouble if we were just managing our code normally. I've emptied my trash. They're all deleted. You'd have to go into like actual file recovery. But with Git, remember Git as long as we have that .git hidden directory, we should be able to save us and get us back to how we need to. So if we have a look, there's a command here. I'm going to reset our branch back to the master branch. So this is an example of, oh, I did something very, very wrong. I just want to get me back to my master branch, the last commit that I had. Please save me. Issued the command, and lo and behold, there's all my files back. Saved, thankfully. So yeah, if things go wrong, Git can very easily, or sometimes easily, get you out of that problem state that you're in. But if you're committing a lot and having branches and doing good commit messages, you should be in a good spot, whatever happens. Right, so that is the basics of workflow for your local Git project. We're going to talk about some collaboration next, which hopefully is going to be about right. It's going to be about the last half hour. But before we do then, we'll have about a 5-minute break for us all to catch our breath. That was probably a lot of information for us all. So I hope you've followed along. If you were following along, good job keeping up. If you were just watching, that's a good thing as well. Hopefully there's nothing super unfamiliar for when you do want to try it yourself. And as I said, these slides for the workshop are pretty much step by step. You can just track through them in your own time, or this workshop's being recorded as well. You can come back and watch the recording. So we'll take 5. I'll be off camera and muted for about 5 minutes. Feel free to post up any questions or catch me when I get back. And we'll move on to the last bit. If you haven't set up your, have a go and set up your GitHub account if you haven't done that already, because we'll be switching over and doing some GitHub stuff. Yeah, thanks a lot. I'll catch you in about 5. All right, welcome back. That is my share screen. Any questions before I move on? Any comments? Anything that was super easy, super tricky? Anyone completely lost? Hopefully we're doing all right. So we'll keep getting stuck in. So we're going to introduce some basic workflow for sharing and collaborating with others. So this is direct collaboration. So basically we need to manually curate the list of contributors who can modify the repository. So that's you guys. You guys are going to be the contributors. Good for small projects like uni projects where you know the people that you're working with. Larger projects are managed slightly differently. Like big open source projects are a bit different. And the exact method for that is not part of this workshop. So we need a remote repository to work with. So if you remember before, a remote repository is a repo that's hosted by some third-party provider. They don't always need to be third-party, but most of the case, the easiest way is to get it hosted by someone. And we're going to use GitHub. So I will open up GitHub. Just through the web interface. And what have I said to do? Create an empty repository via your hosting provider's interface. So it's going to create a location on the servers where your repository is going to live. Okay, so if I remember correctly, new repository. Great. I'm going to call it up 2020. So this is typically the name of the project that you're working on, some memorable name. Example repo for Sim2 workshop. So we've got an option whether to create a public or a private repository. This is going to be I'm going to make it public, and I'm going to choose who's going to commit. But it means anyone can see it. So someone could come across my GitHub profile and look at the repositories that I've got, and because it's public, this one would show up there, which is fine. So sometimes you can add some files that get included automatically. I'm going to create a blank one because I've got a repo on my computer that I'm going to push up to this one. So I'm just going to do a blank repository, so I don't need to add any of these extra files. Perfect. So there's some ways and some info that we're given to it, but at the moment it's just an empty repository. There's nothing in it yet. There's a couple of ways to create these. This is one way. First thing that I need to do, so I've just created that location on the server. I need to push my local repository up to the hosting provider. So that action is called a push, where I've got something local, I'm going to push it out to my remote repository. First thing I need to do is tell Git, or tell my project. So in this case, I've got a project on my computer. It's called up 2020. So I named it the same thing as what my repo is going to be. And I used this last semester. So it's got some commits from someone else who was doing the workshop last semester. But this is the state of the repo. So it's got some commits in it. Git log. So there's some commits in there. Git branch. I forget what branches there are. I think I've got 2 branches there. So yeah, it's just a little repository that's got some basic things in it. So first thing I need to do is tell this project on my computer, my local, where does the remote repository exist? So Git Remote Add Origin. So Origin is a standard name for your sort of main remote repository, and then the URL is grabbed from up the top here. So this is the URL for that Git repo. So I'll also paste it in the chat, and you guys can visit my GitHub page and see this repo via the GitHub web interface. So I'm adding the location of this remote repository to my local Git repo. I hit enter, that should do it. And then I can just verify that I added remote-v. I can see there I've got two different origins for slightly different interactions, pushing and pulling. Origin, I've just had a question if origin is equivalent to master. It's not quite. So master is a branch. Origin is the name that we give for the entire third-party hosted remote repository. So in sense, it's a whole different Git repository, but one that exists on someone else's servers. And we've just called it origin. And that's a bit of a typical name. So we might, we could call it, you know, Joe Blogs or something like that. And that would be the name of our remote repository that we push to. So it's different from a branch. A master is a branch, and origin is the name of a remote repository. So then once I've set up the remote repository, I need to push the contents of my local repo up to that remote repository. So that's done by that next command, git push origin. I'm pushing everything up to the remote repo. So this is sort of the first one. So you don't always have to do this. And this is a sort of different way of doing things as well. So git push origin mirror. URL has no scheme. Haven't seen that one before. Let me just do. Try enclosing that in quotes. Credential URL cannot be passed. Okay, so this is always the issue. I just don't think I'm got the right credentials signed in. So let me see if I can quickly resolve this. Config. What is my GitHub account? Jonathan South. Nope. Nope. This Git's going to give me a fight tonight, isn't it? Let's see what I can do. Okay, so I've got a bit of a credential issue going on. I didn't have time to test this beforehand. I haven't been able to get it going, so that's right. I won't waste any more time. What I will do, okay, what I'll do instead, we'll do it a slightly different way. Let's go to create a new repo. I'm going to create it purely online. 2020-2. Another test repo. Public. Add a README this time. Okay. So there's now a repo just with one commit in it with a simple little file here, a README. So what I can do now is hopefully we can both find this. Where's the, I don't use GitHub that often, just while I'm sort of blundering around. Where is the link? Oh, here, of course. So there's the new link. So if I want to access a repository that someone has provided me, so they provided me the link just like I've done there, in an appropriate location on your computer, what you need to do, you need to issue the command git clone. So git clone, and then the URL for the repo. And that should be able to clone that repo, and then I've got it on my computer and change into it. It was up 2020-2. And then there is my README that I just created online. I've got the commits that I had, git log. So there's a thing, so there's a commit that I made online. So if you clone this repo using this command git clone and then pasting that URL that I gave you, you should see the same things. So now that you've got that code on your computer, it's just like any other local repository. You can branch, commit locally. It's all good. That was slightly different. So as long as the GitHub repo is set to public, anyone can download it and work on it locally. So that's called cloning. That's what we just did then. So have a try at cloning that repo down to your local machines. So that's how you would share. You'd say, here's a link to my GitHub repo. Have a look at it, and then someone would clone it onto their new computer, onto their computer. So this doesn't really make sense because I have changed it a little bit. What do we want to do? Git pull. Let me see if I can do a push up. Let me try this credential trick one more time. Yeah, different credentials can be very annoying. No, something's broken in my Git since last time, apparently. All right. So in that case, let me see if I can edit some code online. So yeah, this is what I'm talking about repository providers providing some usually simple ways of creating and interacting with your repo online directly on the remote one. This is hello from what is this? GitHub web browser. Okay, so there's my file that I've made. Here's my commit. There's a commit message, create hello.txt, create a new file online, and then some committing options here. So this is what I'm talking about. We're already familiar with what a commit does, so I shouldn't need to explain that too much. Commit directly to the main branch. Yep, we can do that. Commit new file. Great. So there is my 2 commits and 2 different files. Now, if I wanted that locally, let's see if Git Pull works. Yeah, we've got a merge conflict here. So I've got mine in a bit of a state, which is fixable. But does anyone want to have a try at, has anyone managed to clone into this repo? Has anyone managed to issue Git Pull and see any changes? This isn't quite working out the way that I was hoping. I didn't have enough time to prep my credentials, apparently. It's a little bit annoying.
Did you add the new link? I can only see the old one in the chat.
Oh, yeah, okay. Oh, yeah, whoops, I accidentally pasted it in a private message to someone because Zoom loves to do that. There's the new one. So you can visit that through the web interface, but ideally we want to clone that repo. Git clone.
Yeah, I managed to clone into it.
Excellent. Let's see if we can get some collaboration going. Do you want to be added as a collaborator and see if you can push up a change to that repo?
Yeah, sure.
All right, so what I need to do is I need to add you to be a collaborator. So under the repository settings, you can manage the access. And so I haven't invited any collaborators yet. So you just click on invite collaborator. So did you manage to create a GitHub account? Perfect. John P. Morgan. Okay, so I just add you. And it says pending invite, so you should get a, I don't know whether it appears via email or through GitHub itself.
Just having a look. Oh yeah, it came through as an email.
Sweet. So there's probably a link to click or something like that.
Cool. I just added click to link.
Great. So we've switched over from pending to you're now a collaborator. So you should be able to see, you know, you would probably be able to commit via a web browser like I was doing if you wanted to.
Yeah.
But ideally, let's see if we can get you committing from your own local command line and pushing up those changes. Because yeah, unfortunately my Git credentials have gotten all twisted and it's fighting back very hard. So what you want to do, if you've cloned into that repo, just create a new file, any file, just a text file or something like that. Just saying hello or something unique, doesn't really matter.
Cool. Oops. Okay, so I've added a file and committed that locally. So now do I do git just push?
So if you commit it locally, yeah, try git push.
Okay, so something happened.
Okay, so I'm going to refresh my online version. Did you get any error messages, or did it seem to?
No, it says completed with one local object to that.
To the URL?
Well, it's a URL, but it's got my username rather than yours.
Yeah.
Master to master.
Okay, that should be good. Sometimes it can take a second. So what did you do? Just add a new file?
Yeah, just a text file.
Yeah.
Actually, I might have done. Oh, hang on. Sorry, I think I've actually been. I think I did that to a different. I'll just try cloning it again because I think I.
No worries. I might try cloning it again as well. It's broken on my end. See if I can get back to where I want to be.
Okay, it seems to have worked.
There we go. So I've just refreshed my online repository and we've got a commit from the other john.txt. Perfect. So then you've pushed up to that repo. If I can convince I think I can pull okay. Git pull. For me, it's going to say there's been a new commit ready for me to pull down, and it has done that, a commit from the other John. And now I've got that change on my local computer. So essentially, we interact with each other or interact with the code via that remote repository. So that's sort of the thing that has the say of who has access to what, that remote repository. So it seems a little bit roundabout for if it's just between you and me, but you can imagine if you start getting like 5 people or more or something collaborating on a project, you need to make sure everyone's working with the same versions of code and everyone can see what's going on. So everyone's got access to the same information. They know what the commits are, they know what the branches are. You can talk about that sort of stuff rather than, a file sitting on a Dropbox that, not everyone has access to or things like that. So yeah.
So if I'd added a file that was, say, hello.txt as well,
Mm-hmm.
when I tried to push that, would it try and just merge it?
Well, so you have the hello.txt file on your computer. So
right.
if you can edit that, so you can try editing that. And why don't you try it and do another push? It shouldn't give you any troubles.
All right.
Hi, John.
Hey, yep.
Yeah, I'm trying to push. I modify the hello.txt file, and I try to git push, but then it prompts me a GitHub login. Why is that?
Yeah, so I haven't given you. First of all, I haven't given you permission to be a collaborator on that one. So if you,
it's a private, is it?
it's a public repo, but you need to have explicit permission to make changes to it. Right. So by doing a push, that's a change of the actual remote repo. So you could do whatever changes you like to locally. You could, branch off and commit and whatever you like based on what's there. But in order to change it, you need to be a collaborator. So if you give me your GitHub username, I'll add you as a collaborator as well.
Sure.
Yeah, cool. I just edited hello and it worked fine.
Awesome. So yeah, things work when changes are easy. When changes become a little bit tricky in terms of when things are different or very different, it can get a little bit harder to manage. It's, this could be probably a week-long crash course for learning Git inside and out, but 2 hours is sort of just scratching the surface a lot. So this is sort of not exactly how you would use it, but it will give you the tools in sort of what you need to be familiar with and how it works broadly. So yeah, if you've got a few different branches, or what would we probably say that would work? Yeah, probably. Yeah, if Luke can become a collaborator,
permission to your Git denied.
Yep. So your invite is still pending. So just check out the
Have to go to.
email, I think.
Oh, okay.
So there should be an email there.
From within GitHub or?
It just came through to the, John, correct me if I'm wrong, that would have just come through to the email that you signed up with.
Yeah, that's right.
GitHub. Yeah. So whatever you
Okay.
signed up with GitHub with, check that email inbox and there should be an invitation there.
Yes.
I actually have to head off, but thank you.
Yep.
Thank you, John.
No worries. Thanks for joining. Appreciate it.
Cheers. Yeah, bye.
I'll see ya.
Okay. Rejected.
First of all, do a Git pull.
Again?
Yep. So that will make sure that everything is up to date. So with the other John, he was editing some things and making changes. By doing a Git pull, that makes sure you've got the latest information on your computer. So
Pulling is not possible because they have unmerged files.
Okay. Yep. So you must have a different file on your computer that's different for what's.
Oh yeah, because I changed the hello.txt.
Yeah. So that's saying that's Git saying, I want to try and bring in these different things into your local computer, but you've got some stuff that's different.
Can I do hard rebase or something like that? Or?
Yeah. Do the reset.
Reset. Hard reset.
It was this one here. Git reset /hard and then space.
What I know there's because I use Bitbucket, so it's all clicking buttons and all that.
Yeah.
So I know there's other setting other than hard reset.
Yeah.
What does that do?
No worries, Sampath. No worries. Yeah. So basically, there's depending on whether so I use Bitbucket for work, and as I said, Bitbucket is just the remote host, and yeah, they obviously provide some different ways to interact with some Git commands. So on the Atlassian servers, on the Bitbucket servers, they'll have essentially a Git setup that it's running the commands that you're giving by the web interface. So the different flags, like if you're doing a reset hard, so this is basically what it does with the changes that you have. So hard basically throws away any changes that you have and doesn't care about them. Some other ones will treat those changes differently, I believe. So we'll say, oh, the changes that you have made, maybe we want to store them somewhere else, but hard just says, no, just get rid of them.
Yeah, I tried to do reset. It says ambiguous argument masters on no revision or path not in the working tree.
Try main. I think the branch is called main for these repos.
Oh, so you can count any things that's different, is it?
Yeah.
Okay, and then just.
And then do a pull.
All right.
If that seemed to work.
Yes. Oh, I think it merges already. So it doesn't delete the text message. Oh, okay.
So that should have. I'm not sure what.
No. Tip of your current branches behind its remote counterpart. Integrate the remote change before push. I did do Git Pull.
Okay. If you're comfortable sharing your screen,
yeah, sure.
That could be helpful. I'll stop.
Oh, yeah.
I might have to give you permission. Yeah, all good.
You see my comment?
Yep, there we go. Just I can't quite see the bottom.
Right. Is that
That's better.
okay? Yeah.
Unmerged files.
I think I'll just do reset again.
Yep. Yep. Can you do?
What is head? again?
Okay. Head is what we're currently looking at.
Okay.
Can you do git log?
From here.
Yeah. So see, you've made that commit. Luke says hello. So we need to essentially get
Delete
rid
it.
of that commit. So I think we reset it, but we didn't.
So reset won't delete my current comment, is it?
Do okay, do git reset --hard and then capital HEAD for head, all capitals, yep. And then the caret symbol, so shift 6. Try that.
What? No.
Yes. Put Y and then enter.
Heady.
Interesting.
So
okay.
I just do
that one again and just hit enter.
Yeah. No. No.
Okay, where are we at in git status? We've probably just completely.
I think I messed up a lot.
You have.
Diverge.
We've completely broken everything.
Skip put the merger. So Git Pull again.
Probably working more into a hole. So this is there's a slide in that from the from XKCD, which was like, what do we do when things break? It's just like delete everything and clone it again. So we might do that and then.
Okay, how do I get?
So go up a directory. So CD --, and then you want to delete the ARP 2020 directory. I don't know what the command is on Windows.
CMD? No.
RMDIR, so RMDIR.
Oh, remove directory.
And then space.
Git.
No, so \x, /S.
Wait. Yes.
Other way, / capital S. And then ARP 2020-2. So that's going to delete everything inside it. Yeah.
What does \S mean?
So that means it'll still delete it if the directory is not empty.
Oh, okay.
Yeah. Okay. Now we do git clone again.
It's checking. Okay, it's not. Okay.
So you can use the up arrow keys, up and down will cycle through past commands. So if you know you've got something that you. Yeah. Cool. So change into that directory. Yeah. Okay. So now you can edit the hello text document. And commit that locally. Okay,
No,
now fingers try. You should just be able to do a git push.
Okay, because I already cloned that. So I have to add and then commit and push in that sequence, right? There's no other way.
Yeah, that's right. So it's you're pushing up commits is essentially what's happening there. So cool, that looks like it worked.
Okay, can you see it? If you open the hello file.
Yep, so last commit was 29 seconds ago, and yep, hi from Luke in there. Perfect.
Okay, yeah, cool.
So yeah, there's obviously a lot of places that you can stumble over. As I found out, usually I have to do a little bit of prep for these, particularly with the credentials. If you start having different accounts and stuff, you know, it can become a little bit confusing. The other thing is I don't use Git from the command line very much at the moment. It's one of those things where you can fall out of practice quite easily. I've been a bit lazy and just been using, I develop mostly in Python in PyCharm, and that has a interface.
Yeah. I just recently moved from Jupyter to PyCharm because I want to package executable Python code, and I don't think you can do that with Jupyter.
No,
Not too sure. Yeah, so I moved to PyCharm and I saw that Git functions there, but I haven't explored it. Do you have time, or you gotta go?
I got a couple of seconds.
Can you show me how do you set up Git on PyCharm?
Yeah, let's see what we can do.
Is that why PyCharm is popular? Because you can just do that.
It's just, I mean, PyCharm's made by, I think, JetBrains, which is, you know, they make a lot of popular IDEs, and they like their general development is the Git interaction is quite good too. Like I haven't had any troubles with it. So, well, let me show you one way. So let me share back. So this is the first PyCharm screen. It's got this get from version control here. So that can be useful. And if you click on that, like it selects the type of version control that it is. And then we've got just a URL there. So what I might do, let's have a look at the NumPy repository. So if we were developers who wanted to develop the NumPy package, have you used NumPy much?
I'm used Panda a lot.
Pandas, yeah.
Pandas a lot. But it's similar to NumPy, right?
Yeah, Pandas uses NumPy behind the scenes, basically. So if we wanted to say, for example, you know, use the source code directly from NumPy or compile it directly, we could come to the GitHub repo and say, give me the
essentially click on their repo and then
yeah, so paste in the URL there.
Okay.
And then I'll just make that a little bit
more. This is essentially Git clone.
Yes, this is doing a Git clone underneath. Exactly.
Just do, yeah.
So I clone that in. Directory already exists and is not all empty directory. Yeah, I know. Well, let's call it, maybe we have to give it a name.
What does that mean? Does it mean that is already assigned a repo?
Yeah, it was trying to, not a repo, but it was trying to call my repo workshops. Okay. I thought it was going to create it with the same name.
Okay.
But yeah, it's doing this. So it's quite a big repository.
Yeah.
We'll just let that go, and then we can have a poke around the source code, and particularly what it means to
I'm just wondering if you can give me some advice, that would be great. Because so I've been trying to find a way to collab in real time. I know this is the more secure way to have a version control.
Mhm.
But do you know Collab from Google?
I've heard of it. I haven't used it or really
Okay.
researched it much, but it looks
Okay.
interesting.
Okay, because I think essentially Collab is like an online version of Python without needing to install Anaconda at all.
Mhm.
So it's ready to go. You can add it in online, so you don't need to install any package or even Python itself.
Yeah,
It's
yeah,
quite useful, and then you can share it in real time. So it's essentially like a Google Doc.
yeah.
And it's useful for, because they use external GPU. You run like on cloud and with external GPUs for machine learning. But I'm just wondering if that is that's so far the best way to go. But I'm just wondering if there's any alternative that you know of, like, or is.
Yeah, not really for real time. I haven't really come across a use case for it.
You have to be this kind of version control push and pull.
Yeah, which is, I think Git certainly scales well. The real time stuff is probably really useful for us, like, a few developers.
Yeah.
But for distributed code, like for something like a big project like NumPy, NumPy, like having this distributed nature is good.
Okay. Yeah. So I'll probably just use Colab and then just copy the code from.
Yeah, I
Colab
think so.
And then put it to PyCharm and to Git.
Yeah.
Okay.
So this is cloned in, right? So this is the NumPy repo. So there's a couple of places where Git comes up, or in general, the version control stuff is under this tab, VCS. And you can, this is where a lot of stuff can happen. A useful one is down in the bottom corner, is the masters. The branches, rather. So there's like 22 branches on the remote. So obviously all of the releases are here, and where they're like working on specific features or fixing bugs or something like that.
Right.
That's where that appears. A useful one is.
But this is like Git clone though, so you're copying directory.
Yeah, well, I've copied someone else's.
But it's now in your local repo, right? You cannot push it back to NumPy unless you're.
Yeah, I wouldn't be able to push it back unless I was.
So all the commit and then the version is going to be stored locally inside that folder.
Yeah, that's right.
Okay.
There is.
So normally you wouldn't be able to just open the files and then see if there's a repository within that folder.
Depends on. Like, I think it's usually quite.
I guess my question is, how do you know if the folder? I'm not sure, because I didn't come from computer science background, so I'm not too sure if I'm speaking the right term. But how do I know if a file have a repository with version control and everything?
Right. So at the most fundamental level, a directory would just be like this top level course manager thing. The thing that makes it a Git repository is this hidden document.
Oh, okay. So as long as I have that .git files, we will know there's a version control.
Yeah, that's right.
Okay.
So it sort of exists in the background, but usually, like, I haven't really come across something where it's like, oh, is this a repository or not? It's like it's pretty clear if someone's like, hey, can you check out my repository? And you just do a clone or something like that.
Yeah. The thing is, I kind of messed up the Git a lot. I don't know the concept that much because I just use Git Bitbucket. But sometimes I messed up the code and everything, and I just reset. But I guess you also delete it and then just re-clone it. If you re-clone it, you can still access the previous version, right? It doesn't
depends on, like, because if you're cloning from scratch, essentially you only have access to
From that
what's
point.
in the remote repo. So you have, let me see.
So let's say I create something today and I made something along the week, and then next week I delete the repo, but everything I've committed and pushed to my GitHub or Bitbucket, but I delete the local repo and then I reclone it. Does it give me access to this week's the previous week?
Yes.
version?
Yeah. So you will have not just like the top level state, you also have all the history of it, all those commits as they exist. So yeah, exactly. As long as it's been pushed up correctly to the remote.
But we'll lose the local commit if it got deleted.
Yes, exactly.
Okay. Yeah. That's fair. Yeah. Okay.
Yeah. So yeah, it's not super magical. If you haven't done something, then yeah, you have a chance to lose it. But like if you've committed and pushed, it's pretty much safe unless GitHub's server farms burn down or Bitbucket's server farms burn down. So
yeah. A few other questions. If you go to, let's say you have version 1, version 2, and version 3, and then now say you're developing version 4, but you realize there's something that you've done that you want to go back to version 1, and then so is there a way to go back to version 1 and just make some minor changes and then remerge version 2 and 3 and then develop 4? Do you know what I mean?
Yeah, I think like this is getting into like specifics. So the best way forward would be to Google your specific use case. But I think the command that you would be after in that case is a rebase, it's called.
Yeah. So that will return me to make my head to a specific past version. Is that what I mean?
It keeps I think a rebase keeps your head at its current spot, but it like you select commits from the past or select a branch from the past, and it changes the way those past commits affect your current head state.
Right.
I think that's what a rebase does.
Okay.
Honestly, my main uses are pretty linear, in that I work with a small team, and it's usually, even though it's a small team, it's usually just one person at a time, working on a particular project or a particular repo. So it's usually sort of that commit and then push up and then commit and push, and you're not really running into too many conflicts because it's a small team. So I'm not super well versed in dealing with the really complicated merges and things like that.
Okay. Oh, good. I mean, it's quite specific. So
yeah, I can't see the thing that I was hoping to show you, which is the version control here. I'll bring up one of my own.
Is there any? Do you recommend GitHub over Bitbucket? Or GitLab, or do you have a preference?
Not really. You
don't use those often.
Yeah, my company goes Bitbucket, just because we were doing at the beginning.
More secure?
No, Bitbucket at the beginning had unlimited private repos.
Yeah.
And GitHub at the beginning had unlimited public repos. There are only something like five private repos.
Now they both have some amount of public and private repos.
Exactly. So I'll just, I want to show you this. This little version control tab here.
Oh, right.
Which
Okay.
appears. Where is it going? Nothing to show. Don't tell me I've completely broken my Git. That would be bad. Usually this little tab here shows log. Here, there it is.
Oh, okay.
That shows the branch structure and how the commits move through.
Why is it squiggly like that? going left and right?
Because that's where that's where we've branched. So this is
and then,
stage of commit, and so this is a branch off here,
merge.
and branching and merging. Yep. So you can see depending on what you're working on and how the commits interact. with each other.
Just there, just the green one, #7. Why does it branch and then merge? But there's nothing to merge to. There's no.
Like this one here.
No, up there, up. What is it? Pull request number 7. No, yeah, that one. But further to the right, there's like 4 different. The blue one, the pink one, and green one. Why is it squiggly like that? Because it doesn't really merge to anything.
No, it's a bit interesting. I never looked at this closely before. Like this one, you can see is the end of like that's the latest. So that's where the branch is. So this is where my master branch lives.
Okay.
So that's the end of that path. The green one has. So what was I don't know what that branch name was, but the green branch did get merged into master. This blue one was sort of here, and then it merged into that branch at that time, but then it diverged again and did this weird thing. I've never seen that before, actually.
Yeah. Okay.
But yeah, I don't know. I'm quite a visual learner, so seeing how it starts off pretty simple, and then can get messy, but ultimately the aim is to keep it sort of neat with 1 or 2 branches.
Sorry, just 1 sec.
Yep.
Sorry. Yes.
All good.
Yeah. Okay. Yeah. Thank you for the workshop.
No worries.
Yeah, that's helpful.
Yeah, I think I'm a little bit. I was hoping it would have gone a little bit smoother with that last part, but what can you do?
Yeah, I know. I mean, it's how coding works, right? You don't know how it works, and then you don't know.
Exactly. But yeah, just get stuck into Google for specific things. I think you should have a decent understanding of what you're trying to do now.
Yeah. Okay. Yeah. Cheers.
Right. No worries. I'll catch you later.
Thank
Lee.
you. Yeah.
Bye.
Bye.